Okay, I'm going to do my next one as a kind of a continuation from the one I just did. Same page anyways. So we have two parallel vertical sheets of infinite extent of carrying a surplus charge, and they are 50 millimeters apart. And we need to determine the magnitude as well as the direction of the electric field in all regions of the space. And so we have two situations here. One in which each sheet has a positive 3.0 the surface density, and then the other two, which the left sheet would have the positive, and then the right sheet has the negative. And so I have drawn a picture of both. So this is where they are both positive, and so the arrows would be facing away from the sheets, meaning that this, because we have area 1 or region 1, area 1, whatever you want to call it, and the arrow is going this way, whereas this arrow is going that way, so they're going in the same direction. So we are going to have an electric field there. But then in the middle here, there will be 0 electric field due to them being in opposite directions. And then we have the same case scenario over here where it's in area 3. We will due to them being in the same direction. And so we need to find the electric field of this region as well as this region, and it's 0 in the middle. And then in this case where this sheet is positive and this sheet is negative, it's going to be kind of the opposite of what happened here, in the fact that on this side, due to them pointing in opposite directions, there will be no electric field, same as over here, but we will, due to the arrow being this direction, so the electric field is going to be in this direction through the middle here section, which I need to find. And so then over here, the field is going to be in this direction that I need to find, and then the field is going to be in this direction, pointing in this direction that I need to find. So we know that the electric flux has the equation of charge enclosed divided by E naught, and then we also know that the electric flux is equal to this equation here. If needed, we will see. And so what I can do here is I know 3.0 times 10 to the negative 9 coulombs per meter squared is our surface density, surface charge density. Wow, I'm having a hard time saying that. And so, well, we want the charge enclosed, and so in that case, we're going to have to divide that by 2 E naught, because so it's going to be for the E net, it's going to be E 1 plus, why do I keep saying E? It's going to be surface area density divided by 2 E naught. And so what we'll do here, plus, because we're adding these two surface densities. So we're going to do 3.0 10 to the negative 9, 3.0 plus 3.0 times 10 to the negative 9 coulomb meter squared. And then we're going to divide that by 2 E naught, which is, E naught is, oh goodness, hopefully I can remember this, 8.85 times 10 to the negative 12, I think. So what we'll do here is that's a loud clicking noise, sorry. Okay. .85 times 10, -12. Okay, and so what I'm getting is around 339, and we can say voltmeters because we're doing electric field. Sorry. Of section 1, which is also going to be the same as section 2 because they're the same charge. Oops. No, sorry. Section 1 as well as section 3 because they're the same charge, so we don't really have to do the math over again. That would be redundant. And so over here, what we're going to do is we're going to have 3 times 10 to the -9 coulomb meters squared minus, but it's going to be negative, so plus times 10 to the -9 coulomb meters squared, all divided by 2 E naught, which we already did the math up here, so we know that, because in this case, E1 is going to be E1 minus, why do I keep saying E? Well, I'm writing it right, so hopefully you're following along. Oops, no. Okay. Okay, so for E section 2 is going to be the surface area density minus of the first, this is number 1. I guess I should say that. Number 2. This is number 1. This is number 2. And so it's going to be a subtraction. So due to this being negative, it turns into a positive here for section 2. And so, and then for the other ones, they are addition, but due to the negative charge, it ends up being a subtraction. And we already know, due to what we've learned in class, that these are going to cancel out, so I don't need to do the math on that. And it again is going to be 339 voltmeters for E2. And then for E1 and E3, we're going to have around the same. So because the charge isn't changing, it's just in one case we have a negative, and then in the other we have a positive. So you're just really looking at the relationship between electric fields and the direction that they go, and so they do cancel out in cases where it is opposite of each other. So there we have it.